In today's video, we are going to be studying aldehydes, and here we have the outline of what we'll be discussing. What are aldehydes, the carbonyl group, synthesis of aldehydes, and uses of aldehydes. Now let's start with the first on our list. Now they are a group of organic compounds that contain a carbon atom that is bonded to an oxygen atom by a double bond. And it looks something like this. Now this functional group is known as the carbonyl group, and it's peculiar to certain group of organic compounds, and the aldehyde is one of them. Now in the aldehyde, this carbonyl group is bonded to carbon on one hand and to hydrogen on the other hand. Okay, of course now the aldehydes form a homologous series of compounds. So this is what aldehydes are. Of course they are organic compounds, and as we can clearly see, they are non-hydrocarbons because they contain oxygen, and in other words they contain more atoms than carbon and hydrogen, which is what a hydrocarbon is. Now let's take a look at the carbonyl group. Now, as I earlier stated, the carbonyl group is simply the group of an oxygen atom that is bonded to a carbon atom by a double bond. Now, the carbonyl group contains a carbon atom that exhibits the sp2 hybridized orbital. Now, of course, we know by now that the sp2 hybridized orbital is made up of 3 subshells. Okay, one subshell here is from S, and then we have 2 p subshells. Of course, we also have an unhybridized p subshell. Okay, now of course these contain electrons. Now, one of the hybridized electron is used in forming a single bond with carbon on one hand. Okay, so we have a single bond here with carbon, and the other hybridized orbital is used in forming a single bond with hydrogen on the other hand. So we have hydrogen here, and of the 2 bonds that exist between carbon and oxygen, so of these 2 bonds, one bond is a sigma bond and another bond is a pi bond. Now the sigma bond is formed by when one electron from the oxygen atom binds with one hybridized electron that we have here. So we would have an electron from the oxygen atom forming a sigma bond. Now this unhybridized electron that we have over here is used in forming a pi bond with the oxygen atom. So we would have a pi bond formed in this way. So this is how the electrons are arranged. This is how they are configured. Now, of course, we know that carbon has a lower electronegativity as compared to oxygen. This means that the carbon atom would exhibit partial positivity. It would be partially positive, and the oxygen atom would be partially negative. Now, although the electrons are actually being shared, from here we can see that the electrons are being shared. Oxygen has a stronger grip on the shared electrons as compared to carbon. So this means that carbon would be partially positive and oxygen would be partially negative. So the carbonyl group has a polarity to it. Okay, now let's take a look at the synthesis of aldehydes. Now, a way in which we can generally represent aldehydes is R. Of course, we have the carbonyl group here and we have the hydrogen on the other hand. Of course, R here represents an alkyl group. Okay, now Aldehydes are synthesized by the oxidation of primary alcohols. Okay, now in our video on alcohols, we discussed that primary alcohols are alcohols which have the hydroxyl group bonded to a primary carbon. Now, a primary carbon is a carbon atom that is bonded to one or no carbon atom. So if we have a terminal carbon atom, if we have a carbon chain that looks like this, a terminal carbon atom such as this one, which is bonded to one other carbon atom, is said to be a primary carbon. Okay, so this is bonded to hydrogen, 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 and it's bonded to just one carbon atom. Now this is a primary carbon atom, and if we had an OH group attached in this way, then it would be a primary alcohol. Now in a situation where we have something like methane or methanol, whereby we have just one carbon atom, and this particular carbon atom is bonded to no other carbon atom, this is also a primary alcohol. So an aldehyde is formed by the oxidation of primary alcohols. So what exactly is oxidation? Oxidation in organic chemistry is simply the replacement of a hydrogen bond. Rather, it's the replacement of a carbon-hydrogen bond with a carbon-oxygen bond. Okay, so anytime the carbon-hydrogen bond is replaced with a carbon-oxygen bond, then such organic compound has been said to be oxidized. Now we know generally that when hydrogen bonds to an atom, especially a non-metal, okay, it has a +1 charge. And when oxygen bonds with an atom, it has a -2 charge. Now, of course, for carbon, the charge for carbon varies depending on the atom. And if we are to calculate this, assuming this bond to be a neutral bond, then we can calculate the charge for carbon to be a -1. Okay, and we can also calculate the charge for carbon here to be a +2. Now we can see that when the carbon hydrogen bond is replaced with a carbon oxygen bond, the oxidation number of carbon increases from -1 that we have here to a +2. Now this increase in oxidation number is associated with oxidation. So whenever an atom or a compound is oxidized, it shows an increase in its oxidation number. So of course this also fits with the general definition of oxidation that we are already familiar with. But generally in organic chemistry, when a carbon hydrogen bond is replaced with a carbon oxygen bond, then such organic compound has been said to be oxidized. Okay, so let's take an example of this using methanol. Okay, so we have methanol, and methanol has the formula CH3OH, and its structure can be represented in this manner. Okay, now we have a carbon hydrogen bond here, and a replacement of this carbon hydrogen bond with a carbon oxygen bond is referred to as oxidation. Carbon atom breaks its bond with this particular hydrogen, okay, and it also breaks, and the oxygen atom here breaks its bond with this hydrogen, okay, in order to form a double bond. So the bond here, the bond that we have here highlighted in purple, is made of an electron from hydrogen and another electron from carbon. Okay, so we can imagine it that carbon retracts its electron and hydrogen also retracts its electron. Now in this case, the bond highlighted in yellow between oxygen and hydrogen is made of one electron from oxygen and another electron from hydrogen. And of course, oxygen retracts its electron and hydrogen also retracts its electron, and thereby breaks the bond that exists. Now, the electrons that have been retracted, both from carbon and oxygen, now form the double bond in aldehyde. Okay, so we would have carbon and a double bond between carbon and oxygen, and then would have one of these hydrogens here and another one of the hydrogen here. Now this is an aldehyde, okay, and this aldehyde is a one carbon aldehyde, so it would have the prefix meth. Now aldehydes are named with the suffix now. Okay, so this or rather this aldehyde would be named methanol. Okay, because it's a one carbon aldehyde. Now let's take a look at the uses of aldehydes. For this video, we'll be considering the use of the aldehyde methanol. Okay, now methanol has the formula HCHO. Okay, and it can be represented like this with oxygen atom here. Now this particular aldehyde has the common name formaldehyde, and formaldehyde makes up a large percentage of formalin. Now formalin is used as a preservative in the laboratory. It's used for embalmment of bodies to prevent spoilage. Okay, so formalin, which contains formaldehyde, is used to preserve tissues, preventing them from decaying, and thus it's used for embalmment. Okay, this is one use out of many uses of aldehydes. We have come to the end of this video. If you liked this video, please give it a thumbs up and don't forget to subscribe. Thank you for watching. Bye.